Our next panel features 4 of our incoming class of 2022 fellows to discuss the commercialization journey in the patenting process. It is being moderated by another of our incoming fellows, Professor Emil Tsai. Help me in welcoming Professor Tsai to the stage.
Thank you.
Do you want to be in the center?
You want to stay at the podium?
Yeah, stay in the podium. Is the speaker on? Can you hear me?
Oh, that is bright.
Thanks everyone coming to the fellows panel. The fellow of this panel coming from very diverse background of medicine, biomedical engineering, neuroscience, renewable energy, from the leading institution of Ohio State, Princeton, Cornell, and Illinois Technology. I will introduce them shortly. They have extensive real-life experience and translation from academia to industry. Together, they are about 200 years of experience to innovations. We know there's no cookie-cutter approach to succeed for commercializations. It's a high attrition rate from academia for commercializations. The panel have a high successful rate so far against all odds. And I will ask 3 questions for the panel at in the following half an hour to learn from them. At the end of that, we would open the podium to you all. First, I would like to introduce Professor Robert Anderson on my first right. Professor Anderson received a bachelor's degree in chemical engineering from Illinois Tech, an MBA from Northwestern in 1984. He's from oil industry, but that's not a dirty name. He worked almost 4 decades at the Universal Oil Product and pretty much runs through all the titles he can, including a CEO, a subsidiary, Vice President of Quality and Productivity, Vice President of Marketing, and he's now retired, but not retreated yet. He's in charge of technology transfer in Illinois Tech, and also teaching classes of economics, energy, and environmental economics. And the most important title now is that he is the chair of the member residential association. And I just learned that the community he retired to pretty much is millionaires or billionaires. Second, I would like to introduce Professor Peixuan. Professor Gao is a pioneer RNA nanotechnology. He has 3 endowed chair positions in 3 different prestigious universities. I don't know how he did that. And currently hold the rank of Sylvan Frank Endowed Chair in Pharmaceuticals and Drug Delivery and the Director of Center of RNA Biotechnology and Nanomedicine at Ohio State. He served, there's a long list of honors, but I'll make it short. He has served as the Director of NIH Nanomedicine Development Center from 2006 to 2011. He was director of NCI, National Cancer Institute, Nanotech Platform Partnership Program from 2012 and 2017. He has 70 patents, he received Innovator of the Year at Ohio State in 2021. That's Professor Gao. All right, and number 3 is my favorite because he made very good tamale. He's a fly fisherman. Professor Prud'homme, I just realized he's a descendant of a gold digger. So that's why he's here. Okay. He's a professor in Department of Chemical Engineering and founding director of engineering biology program at Princeton University. He received bachelor degree in chemical engineering at Stanford after service in U.S. Army, okay? That's the only one I bump into today. We call a wise kid from World War II, right? He's a wise kid from Vietnam era. He joined a graduate program in environmental science and public policy at Harvard, where I also faculty for more than 10 years, and PhD of chemical engineering of University of Wisconsin. He joined Princeton. After that, he pretty much created a field of, we call it rheology or something, right? He's the founding president of the society, of the US Society for Rheology, and director of Princeton NSF, NIRT programs. And his imprinting jet technology developed in the lab has been used in the COVID liposome and nanoparticle vaccine, which myself benefited from. And the technology is also applied by Bill and Melinda Gates Foundation to produce drug for global health initiative. Last but not least, our panelist, Dr. Wang Yadong, is McAdam Family Foundation professor at the Cornell University. His tour of academic institutions started at Stanford University, MIT, Georgia Tech, and now, and then University of Pittsburgh, and now he landed in Cornell University. I don't know why you want to choose the cold place. His expertise is in chemistry, material science, and biomedical engineering. He's a fellow of American Institute of Medicine and Biological Engineers. And also, his research focus on design application of biomaterial. Several of his inventions has been licensed and commercially available for clinical use. He is the co-founder of 3 companies, one of which is marketing advanced medical advice. I don't know what happened to the other 2. All right, that's my brief introduction. And we have 3 questions at the end of this podium panel discussion. We will open to you all. The first questions, I'll step back to the sofa. The first question is, what drove you to invent and commercialize your invention? Because we go beyond invention, we want to commercialize. All right, maybe we can start with Dr. Anderson.
Can you hear me? Sound good? Thank you. So existential threats to our planet from climate change and a lack of clean, sustainable energy drove the commercialization projects I will be discussing later this morning with you. I work both sides of the street, long time in industry, long time in academia, so I speak both languages. University-industry collaboration could have wonderful synergies, but there are so many barriers that I spent 20 years knocking holes in the wall, and I'll share some of those techniques. Many of you are here, I learned in the discussion at the USPTO last night, because you've got a great invention but no path to get it out to the real world from your university, so I will share a little bit of that. Universities do R, they don't do D. D is 10 times as expensive, and there are very few of them that can do that. Potential licensees of stuff. Now, I don't do drugs, I do things, machines, and that. Licensees want to see that your invention works outside the lab, that it will work at scale, and that it's economic. And I'll explain later how we did that.
Yeah, I think from my perspective is professional. A lifetime responsibility is the creation of knowledge and dissemination of knowledge. So that's why we need to do invention. NIH support us so much of the funding, and without fundamental research, you will not be able to do practice. So without only practice, without fundamental research, you will be able to have invention. So that's why start with the fundamental research first, and finally develop into commercialization, apply feedback to the society.
Very good, thank you. Professor Prud'homme.
So my answer is simple, is I'm an engineer, and an engineer, my passion has always been to take science and translate it to technology to make an impact on society. And so that's why, even though as an academic, patents have been important to me. I have 105 patents, and that's really been the enabling, those patents enable the translation of our ideas from research into technology and applications in companies.
So what drives me to patenting and innovation is really patient clinical demands. I collaborate with clinicians who said, this is the device we have today, it's not good enough, can we do something better? And in the successful company we have, so the 1 out of 3, really the driving force behind that is the founder's wife is going through chemotherapy, and she doesn't complain so much about chemo itself, but the pain of removing the adhesive during the what's going on, sorry. So what she complains the most about is the pain caused by releasing the medical adhesive. So that's the really drives our founder to found the company, and now we're selling products on Amazon. So.
Thank you. Look like it's a real world we're dealing with, right? So it's either within the campus or climbing the wall to the society, and that's I see that as a continuum. It's not like dichotomy, academia and industry. But we're open to the podium, how we climb the wall later for that. The second questions, how do you feel, or what do you think are the ingredients for successful commercialization? Professor Anderson, please.
Well, I've had 2 of them via university startups, and I'm happy to share that experience. One was commercialization of technology to prevent lithium-ion batteries from burning and exploding. Another one was to make electric motors way more efficient and easier to control. I learned 5 lessons. The brick wall around the university has no peepholes. Industry rarely climbs over the wall to see what's going on inside, and faculty members probably don't climb over that wall either. Our faculty learned that industry speaks a different language. They have a very short time frame, and they expect you to solve all the business issues. Most of the companies that I worked with had a sign on the wall that said NIH. Now, you guys here in Washington think that means National Institutes of Health. It does not. It means not invented here. Some of the industry barriers that I had to encounter, too theoretical. You don't understand the real world. You're not ready. It's too risky. We have a $100 million R&D budget, and we can out-invent you. My second favorite one, we don't do things that way around here. And my all-time favorite, courtesy of a major automobile manufacturer, was, if it was any good, we'd be already doing it. So I found having a university startup to take things ready for commercialization was the secret. 12 steps. Start with a very clear problem statement. Took both of my companies 2 years to write a proper problem statement. It's not easy. Get the support of the university administration. If you can't get that, benign negligence works just as well. You need a business incubator. We had an unused building on campus. We had a vice president of community affairs that had political pressure to do something with that. So we managed to I won't say scam, that's the wrong word. Managed to attract some money to be able to set that incubator up. You don't have any money? Get the university to give you a license on a no cash basis, 5 to 10% equity in the business. that also aligns your interests. Get the inventor professor involved, but with all due respect to you folks at academia, don't let him or her be the CEO. The university needs a tech transfer officer like me, 37 years of industrial experience, 20 years of university experience doing tech transfer and IP. Okay, maybe a couple of years fewer, but you need to have that combination. We staffed our business with students, undergraduate students and graduate students. We tolerated, actually encouraged noise, fun, craziness, competition, challenges that eventually led to a high-performance team. And my definition of that is a team that delivers 10 times as many results as a standard gang of people. Their role, fail early, fail often, fix it, do it again. We set them out to make 5 mistakes a week. Think about a month. You've made 20 mistakes, and you're probably getting pretty close to having a finished product. We discovered that an alliance, a non-cash deal again, with a company in the industry was very valuable. They let us use some of their machines. They let us go to their trade shows. We set up a card table and chair at their booth, and we could talk to people. Their marketing people helped us understand the marketplace. Here's the most controversial one. Bring a potential customer inside the tent. Understand their problems, create an aligned strategy to solve their problems, let them set product specs together, and forget about secrets. They're already overwhelmed with opportunities in their own companies. They ain't gonna steal yours. An advisory board of retired tech and executives can help. Sometimes they bring a little money, sometimes they bring experience. Contacts, extremely important. Get the city, state, and federal governments involved. Jobs programs, community development, SBIR grants. So have fun, prove your product works and is manufacturable, and sell it to an industry leader. Thank you.
Thank you. Professor Guo?
Yeah, I want to describe something as a university professor's perspective about 4 factors important. Number 1, surely, is an invention in the patent. That's surely very easy to understand. The second one is called conflict of interest. So you need to learn how to work with the university, the NIH, the government, how to deal with the conflict of interest, called conflict of interest management. You need to do it the right way, That's the second perspective. And the third one, surely, is different. To work with the university as an academic leader and work with the company is different. So the team, the management team, how to find a team member, that's the most challenging work for you to do, okay? So surely, another one always is money. You should develop things in there. For example, work with pharmaceutical drug development, you need multi-million dollars to bring into FDA approval. That's money is also challenging, okay? Thank you.
Professor Prud'homme?
I completely agree with you. I think the key element is people. And it's, I have 6 startups. One's gone, public. 2 or 3 are still functioning, 2 belly up. But it's the people. Do you have the right CEO or management team? If you have the right CEO, he'll tell you if your technology is terrible, it's not going to work. So the person will tell you how good your science is. If it's getting your ideas into major industry, again, it's people, it's internal champions. So our technology for nanoprecipitation is used to make all the COVID vaccines by Pfizer and Moderna. And again, it was champions within Pfizer and Moderna who took our technology and convinced senior management this was the way to go. So again, it's people and relationships, and that's just key to success.
Thank you.
So from my experience, it's really same thing. It's a people. It's a team of people who have the technical expertise and also the tenacity, its experience to transfer something from a concept to a real product. At least in my experience, the first concept probably always going to be failed, and you need to pivot, change to something a little different or modify to make it actually work in the commercial space. And one thing we realized pretty early on is when you're doing something in the lab, if it cost is actually not much an issue, when you think about marketing, costs become a very, very important issue. So the formulation you had in the lab may not be the one that can be commercialized because it's too expensive. How can you keep that same ingredient but make it acceptable price-wise to the market? That is something the CEO will say, yeah, it's a great product, but nobody can buy it because nobody can afford it. this is your competitor. The competitor selling this at this much price, and yours going to be this much more. You can't sell that. So I think the reality of the market and the innovation you have in the product, the two needs to match in the end, reach a compromise, and then that's when I think when you're going to have a successful product.
Wonderful. Look like the attrition rate because of the people, but I would say also because of funding. And not to expect high percentage rate of success. I would say shooting for, you start with multiple IP, multiple idea, multiple IP, multiple business entity. That's a key.
90% of the startup company fail within 1 or 2 years.
Most of them.
Yeah, most.
Yeah. Now we come to the last question, but I think it's the most important question for us all. How does your innovation support the future of a sustainable society or civilizations? Professor Anderson.
Well, he's already said that I came from the dark side. The things I worked on in the oil business, though, had to do with catalytic converters, which gives people something to steal these days for the platinum. Lead-free gasoline, getting the sulfur out of all the fuels and so forth. So I've been working on alternate energy systems for many, many, many years. People are sitting around waiting for the next big technical breakthrough, which is baloney. The challenge is one of political will and education. I recently gave a talk on economics to about 100 highly educated people and gave them a quiz. None of them knew anything about the law of supply and demand. If we can't understand that high gasoline prices should drive you to a bicycle and not to writing your senator to take over the oil business, we got a long way to go. There are very, very few politicians who understand this, but until we get the national will that says we got to fix this, my timeline is 11 years. The world's already uninhabitable in many places. If you're in Nigeria at 130 Fahrenheit, that's not sustainable. And the rest of the world is going to see the same thing between the floods and the droughts and the food shortages. So we got about 11 years. We'll mess around for 10 and a half. And then finally, when people start to die by the millions, perhaps something will happen. But the technical answers are all done.
Well, I hope the air is getting better. Unlike Seattle, which has 107 2 years ago. For physical sustainability.
Yes, yeah. On the stage, I worked the fundamental research on the viral DNA package motor. I constructed this viral motor and also discovered that the viral motor was killed by the RNA molecule. And we published in Science, PNAS, and Nature many times before. However, during the study, I also, my career as a witness, many people in the society have suffered from the cancer problem for many years. So I think 10 or 15 years ago, I started to move that to see that we can solve some of the problem of the cancer therapy for human beings. Those were rather than only focus on fundamental studies. So what we found out is the RNA molecule is that or animal. It can move, it's motile. They can find the cancer spontaneous by cell. It's surprising to see this kind of thing. Besides the specific targeting, still spontaneous to find the cancer by cell, inject into the body, and after half hour, they find their way to go to the kidney excretion to the urine. So without targeting to tumor, the rest of everything go out from the body by itself. There's no toxicity. So now we find something specifically target to tumor, to cancer, and then no toxicity to human being. So that's why it's really exciting. I feel that why we not move it into the company to develop some drug to the human, so we find it about tens of hundreds of nanoparticle by cell that can treat 7 kinds of cancer by cell in the preclinical trial. That's why drive my energy and interest to work in the cancer therapy use RNA nanotechnology. So that's why I really set up the society called International Society of RNA Nanotechnology and Therapeutics. And also I hold conference every once a year. I think in the in 2020, at the time, the whole society declined about the RNA therapeutic. They feel it's impossible. So company billion dollars to this field, and they all fail. So I start to join the conference once a year, collect money to move a year. And I feel we need to set up a company to produce this kind of RNA to the society. That's the high tide of bring the ship to the shore. So that's why I start to collect about $4 million from all my relatives, friends, colleagues, and family to start the build company. I'm not really looking for rich. I'm looking for whether we need to solve society problem by itself. We work for decades without moving into the clinical application. Our resources were useless. So that we have an opportunity to do it. Why not?
Thank you. Professor Prud'homme.
So for me, sustainability, my focus is really on global health, to take our really expensive medical therapies we have in the developed world and to get them into low-income countries and to underdeveloped countries. So that's the Gates Foundation has sponsored our work to take our technique for making nanoparticles. They have funded WuXi AppTec to have a line to make an anti-malarial drug using our technology. We're working under the FDA sponsorship to make COVID vaccines that don't require cold chain storage, because that's the thing that limits the mRNA therapeutics being adapted in sub-Saharan Africa, South America. So things that we can do, to my mind, that make an impact in the global health is what I'm interested in.
Thank you. Global health. Last one, but not the least.
Yeah, so the core expertise we have in our lab is design materials. And it's fortunate that because we're interested in biomedical applications, the biomedical materials we work on, I believe eventually needs to break down into molecules the body can use. So on the other end, designing end, we use the starting materials that's originated from plants or animals. So there's a sustainable resources, renewable.
Thank you. Yeah, we got 5 minutes left, so open to every one of you, please. Yes, please. Yes.
Good morning. I come from India. So these are two different worlds, the developed world and the developing world. And the issues related to the value of IPR and the participation by industry is totally different. In United States, you own all IPR. In our country, the IPR is not owned by the institutions, and the industries want to exploit the academic IPR. So I was the president of a university for 10.5 years. I changed it, and I said 50% industry, 50% the institute, which they agreed. And they have a first right to refusal. One of the things which we find, which is at odds, is we don't have technology transfer office or technology licensing office. That is a very big issue. And if somebody steals your IP, then you go to the court, it takes ages. That is a very big problem in protecting IPR in developing countries. And I want to tell you the last thing. Ours is a very small institute, now 90 years old. 8% of India's GDP is created by the alumni of this single institute. So that is what we realized. More than 800 first-generation entrepreneurs have been created by my institute. And everywhere, so they help us in running our programs. But it is an exception in a country like India than a rule. This is what I just wanted to add to your discussion. Thank you.
Thank you for the wonderful questions. I have two reflections. Number one, our president just hosted the Prime Minister from India. Look like they are in very good working relationship. Number two, I think for your the question you raised about the IP protections. Personally, I traveled to India last summer to serve in a very remote hospital. I'm struck that their budget is a small percentage of regular biotech company, but it serve big populations. So how we bridge the gap internationally. Because for sustainability, it's going to be global. It's not U.S. business. Oh, it's not like we can separate it, United States from the rest of the world. Professor Prud'homme, you have any?
My daughter is on the Duke Medical School faculty, and they live in Kenya, and she does malaria research. And her goal is how to take the Kenyan medical system and use it optimally to treat pediatric malaria, essentially. So I think how we in our world can reach out and couple with the growing educational infrastructure, medical infrastructure in the third world is what we can do. So I think Duke is doing a wonderful job of that, and I think that other institutions can follow.
Yeah, I do think, like, for example, during pandemic, we learned a lot from, say, Israel, from South Africa. They got much better information system. I'm sure we can learn something from India, too. There's no cookie-cutter approach to be successful, to commercialize. And that's what I think. The other panel, how we respond to this calling of international sustainability.
I have a comment. The company that I worked for transferred sophisticated oil refining and petrochemical technology to 102 countries. The best oil refinery and petrochemical plant in the world, do you know where it is? Jamnagar. Reliance, the Ambani family, and they said, when you build this refinery, we want to compete with Exxon and Shell and all those guys, BP. We want the absolute best we can have, and that's what they got. So that technique has been used many, 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 many times, training the local people to run it and walk away successful.
Ambani is my student.
Okay?
Here you go. Yeah, so you don't ask us questions, we will ask you questions. All right. Yeah, I think National Academy of Inventors is international, my bias. For example, we cannot just take the carbon away from the sky of the United States. We have to take the carbon away from globally. So we have a challenge. And for the next 10 years, I'm sure it will show both invention and both political power. We'll get it done.
You have more confidence in the political process than I have. I'm older than you are.
Well,
I have more data.
I see half bottle full.
Okay, I'll drink to that.
Okay. We are running out of time, and I'm sorry that we cannot spend more time to continue this dialogue, and I appreciate we can continue the discussions, in the rest of the meetings. Thank you.